Alright, the recording has start, and we can go ahead and begin. Alright, so welcome everyone to the first Teach2Learn meeting. You're just banned from talking. Okay. Oh, were you muted? Alright, let me go ahead and do the unmute command on you then. Cool, should be good to go. Alright, well welcome everyone. We're glad to have you all here. So you're part of the Advanced Kiddo Club, so we're going to have more advanced lecture and more chill atmosphere here. So to begin, I just want to go around and have each of you introduce yourself. Want each of you to say what school you go to, what your name is, some of your favorite programming languages, and something interesting about you. So Bob, you want to start? Make sure you can unmute your microphone.
Hello,
Yeah, you got it.
my name is Bob, and my full name is David, but I go by Bob. Yes, so I actually really enjoy doing computer stuff. I've built it two computers before, and I'm using one right now. One of the computers, it's a gaming computer, 1080 Ti, i7 ninth generation. Also, I do coding, not that much though. I use Blender for making like cool stuff, and I also design games with my friends using Unity Hub.
Great,
And my favorite, like I use C hashtag for my programming language.
great. What school do you go to?
I go to McCullough.
I
I'm in
Nice,
eighth grade.
great. I went to McCullough too. All right, Mr. David, you want to say some stuff about yourself?
My name is David Fernandez, of course. Next year I'm going to McCullough, and I know a lot and learning JavaScript and Lua, and I know a lot of block code from scratch as well, and I know a good amount of Maya is a 3D printing software, but you can also use for modeling things.
Great, that's very cool. All right, guess I can do myself. My name's Jack. I go to the Academy of Science and Technology. Favorite programming languages changes on the day. Something interesting about me? Not too much interesting. I just do a bunch of programming. I do it for money. And now I'm doing it for you. So next up we got, how do you pronounce your name? Sanjan? Make sure your mic is unmuted. Yeah, Sanjan, I don't think your mic is working right now. Make sure you allow access to it. And if it's not, if you can't get to work, oh, I see you put a message in phone box discussion. If you can't get to work, you can just write in there. I can speak it out for you. All right, cool. Well, he's doing that. Can go ahead and go. So, Mr. Dark, uh, what's some things about you?
Um, my name's Advi, and I'm going to go to McCullough next year, and I know like a good amount of coding for some, and I've done Scratch before, and I guess my favorite language would be HTML.
Oh,
Easy.
nice. Oh yeah, you can't get better than HTML.
Yep.
All right, so Sanjan, you get to work. Hey, Nikita.
Hi.
All right, cool. Well, Sanjin, if you can't get to work, you can always message in the Funbox discussion group chat, and I can just read it out for you. You can keep on trying throughout this, and we'll try and get you. All right. Cool. Well, I'm glad to have you all here. Now, for today, we are going to be going over what?
Oh, okay.
Oh, now I can hear you. All right. Tell us about yourself.
So I'm Sunjun, and I'm gonna go to McCullough this year, and I like coding in Python. I also like building computers. I finished building my second one just yesterday.
Very nice. Hey, a bunch of computer builders in here. I built one of my own too. All right. Well,
Nice. What are your specs?
I have an Intel Core i7 with a NVIDIA GTX. I think it's 1660 Super. Yeah, it's 1660 Super.
What about you, Jack?
mine, I got the 8700K, 2080 Rev A, and then yeah,
Cool.
yeah. All right. So for this, we're gonna have a mini lesson going over some cool computer science stuff you can use in real life, and then we'll go back and loop over to just some coding activities. So I'm gonna go ahead and share my screen. Let me just make sure I got this all right for the video recording. Gotta do that. Do that. Move this to here. And there we go. I'm going to share my screen if each of you can go ahead and get that open. You can just click on the little live thing or click on the join to join the stream. Alright, see y'all in here? Cool. So this one is just going to be going over binary. Now I'm going to be talking. If you got any questions, I'm going to be asking throughout. If you got any questions, but you can stop me at any time, or you can just message in the fun box discussion, and I'll answer those immediately. Okay?
Alright.
Great. So first off, we gotta see what is binary, right? So everything on your computer and everything in the world that's digitally stored, so your music, your games, this voice call we're on, is stored in binary. So you may have seen it before. It's the zeros and ones, all of this. If you ever watched a hacker movie or whatever, and you got all the zeros and ones going down the screen, that's binary. So, us humans, we use our various languages. We got English, Spanish, Chinese, etc. But computers don't understand this. It can only use electrical signals. So if you think about it, if we have this little thing and we have this, the only way the computer can know if this is on or not is if there's an electrical signal going between it. So if you got electricity, then it can say, okay, it's on. If it doesn't, it's off. Now, this leaves us with a challenge, right? How are we going to store this? So, scientists a long time ago, over in the 1900s, came up with the electrical switch. So, like we were showing before, the electrical switch can kind of be thought of as a light switch. You have on or you have off. And tell me if you can see this. I'm terrible at drawing, by the way. If you can't already tell, I'm terrible at writing. So if you can't read something, just let me know. So you can think of this like your light switch, right? You can either have the on state, which in binary is represented by a 1, or the off state, which is represented in binary by a 0. So this is great, right? Because now we can say, all right, if we label this running, we can now say if it's running or not, because we can say, is it on or true? Yes, or is it off or false, right? But that leaves us with a big gap because how are we going to store more complicated data? Like my voice that you're hearing right now is stored in binary. You can't just have on or off, right? Oh, Mr. Jacob is messaging me. Let's see if I can help this dude out. For the for this first day, it's going to be a little chaotic due to Discord help. All right. So, how would they store more complicated information? Does anyone have any guess?
A lot of on and off switches.
Exactly. Yeah. So, if you just have one, right, you can only store one. But if you have two, then now we're talking. We can have infinite amounts of them in a row. But unlike our normal number system, right? So like if we don't want to do something where, so like say we got binary number, right? We don't want to have to put 1,000 ones like tally marks to equal 1,000 because that's very inefficient. So what we can do instead, oh, I see two new people joined. Welcome Jacob, welcome Mr. David Perk. Today we're going over a binary lesson. So you joined a bit late. We're in it right now. So if you got any questions or want me to recap anything, you can go ahead and type in the fun box discussion or in my DMs. I'll answer them for you. So yeah, like I was saying, you don't want to have to type 1,000 ones to get to 1,000 because no one wants to do that. So unlike our normal number system, which is base 10, so if you think about it, right, for you to get to a new number place, so have a 1 in here, you have to go through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 different numbers before you can get to a new number place. Binary, you only have 2. It's base 2. You got 0 and 1. Cool. So I'll do a quick poll. This might as well. I'm doing CS poll. All right. So if you go CS polls, you can upvote, downvote, or do the shrug. Just make sure that we all got that. Great. Oh, we got one thumbs down. And oh, that's from someone that's not even in this chat. I knew that would happen. All right. I'm gonna do that in Funbox now on because all the other people are just gonna try and answer. All right. So yeah. So now that we got the base 2 system, what that allows us to do is we can interpret the bases in two values. So in a normal 8-bit binary, so a bit is just a 0 or a 1, we can just draw them out right here. So that's 8 right here. We can say, if we make, for example, this one a 1, then this, we'll see, okay, so that's 0 or 1, that's a 1. But what if we want to add 1 to this? Does anyone want to take a guess of what would happen? If we say we want to add 1 to this number.
You add a 0?
Or here, I'll remove these. So if we're in base 10, what is 1 plus 1?
2.
And if we're in base 2, what is 1 plus 1?
4.
Well, think about it.
Wait, we're in a base 2, right?
Yeah, so we're in base 2. So we got 1 plus 1. So we got 1 and 1. Oh, it starts with 1. But then we can only have up to 2. We can only have up to the number 1 in a single place value. So where does the other one go?
Beside it.
Like this?
Yeah.
Well, if you think about it, oh, I should probably go to octave rule and make more sense. Actually, if so, we take 0, right? We go up 1, so now we're go 0, and then we go up to 1, but then we have to add another 1. So if we add another 1 to this 1, you can kind of see it like this. The 1 plus 1 goes into the new place value because it's equal to 2, which is greater than the max place value. So you can think of this as like being greater than 10, or being 10 or greater. So then it'll come here, and then this becomes 0. Do
That's,
you see how that worked?
yeah.
Alright, so just one more time. If we go 1 plus 1 in binary, you can only have a max of 1. So one of these has to pop over, and then you got 1, 0. Cool. Now, we're now going to go over the exponential rule. So, if you remember before, I was talking about the 1,000 ones equal 1,000. No one wants to do that. It's a lot of work. So, what we instead have is a base 2 exponential rule. So, not sure if all of you have taken algebra yet. If you haven't, there's a thing called exponents. So if you take a number, so it's simple, let's get 2, and we put it to the second power, that would equal 2 times 2, which would be equal 4. And if you do it to third, it'll be 2 times 2 times 2, that sort of stuff. Now, binary works off of an exponential rule. So if we draw out the 8 bits again, which makes up 1 byte, if you ever heard the term byte before, a megabyte, gigabyte, 1 byte is 8 bits. This value right here is interpreted as a 1 because it's simply just 2 to the 1, or 2 to the 0. I'm sorry, 2 to the 0 because it's in the 0th place. Next, if we go here, this is 2 to the first place. So that's 2 times nothing, so just 2. So this is interpreted as a 2. Next up, 2 to the second place is 4. And then what would this one be? Anyone have a guess?
8.
Exactly. Yep, so 8. And then, it goes on and on. So 32, 64, 128. So this may make it a bit more sense why 1 plus 1 equals 10. So if you thought before, right, we had the 1, but to equal 2, we need to go over to this place value. And this is actually great because say we want to represent 18, right? Instead of having to write 8 or 18 ones, we can just do, well, we don't have 128, so that's a 0. We don't have 64, so that's a 0. We don't have 32, so that's a 0. We don't have 16, so that's, or we do have 16, so that's a 1. So then we can subtract 16, so that would be equal to 2, right? So 2 doesn't go into 8, 2 doesn't go into 4, 2 goes into 2. We can then subtract 2 from 2, that's 0. And then 0 doesn't go into 1. So then right here, you've just wrote 18 in binary. Does everyone see that how that worked? I'll put a poll in chat. Alright, the poll is in Funbox discussion this time, so all the other people don't get confused. If you don't get it, don't be afraid to put the thumbs down. I can always go over more.
Wait, where did you put the poll?
In the Funbox discussion chat. Here, I can ping you in it, so you can see it. Okay. Alright, I see 2 people did the shrug. Alright, so what is confusing about it? Sanjay or Dark, either one.
How you get 18 from that?
All right. Yeah. So here. Can you see the numbers good here?
Yeah, yeah.
All right. So you have to kind of see this as different values. So this first 0 right here represents
Okay.
1. This one represents 2. So if we write, so this is a 1, this is a 2, 4, 8, 16, 32, 64, 128, right? Um, so right here, if it's a 0, that means no or false. So there's no 1. So we can just get rid of that. If it means 1, it's true, so we got a 2. So we can take the 2 over here. 4 is 0, so we don't do it. Got a 0 here, but we got a 1 on the 16, so we add 16. And then the rest are 0. So then we can see. Does that make more sense?
Yeah.
Great. And
That
then
makes no sense to me.
Sanjin, does that make sense to you?
Yeah.
Great. Yeah, and you can do this with pretty much any number. So if you want to do, for example, let me erase this. If you want to do 128, you can just do 1, 0, 0, 0, 0, 0, 0, 0. That's 128. And this is generally how numbers are stored. Note that, sometimes if you need a number greater than the total of this, you can always add bits. There's 32 bits, 64 bits, crazy large amount of numbers. Great thing is because it's exponential, you don't have to waste as much storage on them. So now what I want you guys to do is go over to Fun Box Discussion and write the number 5. So just write 5 in binary in Fun Box Discussion and take your time. Just write it in. And if you need help, just hit me up and we got it. And people are going to be posting them, so try not to just like look off of them and copy it.
You said 5, right?
Yeah, 5. And take your time. We're just going to get all of them in. So we got Dark, David, Fernandez, Bob, Senjin. What? Oh, what is Mr. Ashton doing? I guess you can answer that one too. I don't know what he's doing on that. All right, so Mr. Jacob, I don't see an answer from you. Do you need any help?
What?
I was talking to Mr. Jacob Amon.
No, I was just confused about what the poll was about.
Yeah, I don't know. Another mentor just randomly created that. If you want to answer, go for it. All right, cool. So, Mr. Bob, you didn't copy it. All right, cool. So I think that's everyone in. Mr. David Perk, I haven't heard you talk. Are you still doing them? All right, yeah. Cool. Yeah, so the correct answer for that one was 0, 0, 0, 0, 0, 0, 0, 1, 0, 1. So I see Narc got it right. David, on your first one, so what you wrote was 3. Did you see how it was 3 right there? Because
I did not.
you don't. Okay, so when you write 0, 0, 1, 1, which you can also do, you can write 4 if you don't want to write the full 8. Still work. So you got a 1 in the ones place, a 1 in the twos place, a 0 in the fours place, and a 0 in the eighths place. Do you see that?
Yeah.
So if you have a 1 in the ones place, you do plus 1. 1's in the 2 place, plus 2. 0 in the 4 place, so you just get rid of it. 0 in the 8 place, so that just equals 3. Um,
Oh, I did the other way around.
oh, okay. Yeah, no worries about that. So yeah, you would just want to do 0, 1, 0, 1, or 0, 0, 0, 0, 0, 1, 0, 1.
Hmm.
See, Mr. Bob's good. And yeah, Sandra, you're good doing that. Just note that sometimes in actual programs, you're going to want to do either 8 or 4 with some zeros before. Y'all good, no need to fight. It's not competition here. Alright, so great. So, hey, first number written in binary. Give yourself a round of applause. Yay! Alright, great. So, I'm going to do another poll. Just make sure everyone understands. Alright, so go ahead and do the plus one. Alright. Or if you don't get it, just let me know and we can go over it some more. Hey, Ashton.
Hey, what's up?
Not much.
Binary, I see.
Yeah, yeah.
Pretty cool. Cool stuff.
I hope it is.
Hmm. Hey, actually, for the poll,
Mhm.
doing what is this? The slash poll
Yeah, yeah,
is it looks a little bit. I mean, it's up to you. Honestly, it doesn't really matter to me, but I don't
yeah. I'll probably do slash poll. I've just been doing plus poll.
know. Yeah,
Uh,
you're good.
oh yeah, that's a great thing, Jacob. We're actually going to transition into that later on. What's, but yeah, thinking ahead. So yeah, so that's actually what we're doing now. So now that you've written a number, right? But everything's not just a number. You would actually need to write in text. So as oh, um, so computers also store text in binary, but they use it using an encoding format. So I'm gonna go ahead and remove this. So nope, no Morse code. Does not use Morse code.
Yay.
So the really smart people made ASCII in the 1900s, which later became UTF, and you may have heard it as UTF-8. So this is basically what everything, at least in English, uses for their text encoding. So what that means is it takes in a binary value, so some zeros and ones, and it makes it into like a letter, like A. Before then, it was mass mass confusion across the globe because if you don't encode text the same, something sent from one computer to the next would just be garbled junk. So now that there's a standard, we can write binary for it. Now, binary letters in ASCII and UTF-8 start at number 65 and go up. So capital A in 65, capital A in UTF and ASCII would be 65. And then capital B would be 66, capital C 67, etc., etc. Go up for the place value in the alphabet. So what this allows us to do is we already said before, right? Let me put the diagram back up here. We got the 1, 2, 4, 8, 16, 32, 64, 128, right? So if we want to write an A in ASCII or UTF-8, we just want to type in 65. So does anyone know what that would be?
64 and then 1.
Mm-hmm. So that'd be
0, 1, 0, 0, 0, 0, 1.
exactly. So you type in this 0, 0, 0, 0, 0, 0, 1, and that's equal to A. Um, so what I want y'all to do is with this, try and write ABC in binary and put it in chat. And take your time. Don't copy other people, you know. So yeah, A is 65, B is 66, C is 67. And make sure you put a space between your binary values. In real binary, it's not like this. There's space characters, or it's encoded like
Oh,
that.
I see.
Cool. I see some of you put in A. Make sure you do A, B, and C. And no problem there. So yeah, take your time. Don't rush. Don't rush. Yeah, yeah. Did you write this correct? Da, da, B. Yeah, you're writing some lowercase there. Oh, looks mostly correct. So you got a special character in there. You got a period. Yeah. Even with me, you know, binary is kind of slow to decode. um, because you know you've still got to go through all the place values. You got to go individually. But yeah, based on what you put, that does look correct. So yeah, it looks like pretty much everyone got that in correctly. Yay! You wrote your first 3 letters in binary. Give yourself a round of applause.
Wait, we got it incorrect?
No, you got it correct.
Oh,
Correct. Yeah, yeah. um, so yeah, so with this, right, you can write anything you want in binary. And just for quick reference, if you want to write a space character, that's just 8 zeros in a row. Counts as a space.
What characters represent numbers under 65?
Yeah, there's actually the ASCII table. I'll pull it up right here, which has every single representation. So you can see a lot of these are like system stuff. So like you got the can, sin, that kind of stuff. But if you're using UTF-8 table, you actually do pretty much anything you want. So you see you got a left apostrophe would be over here. All this. And let's actually do UTF-8 table binary.
can you write like, um, or can you make like a website using binary?
So all websites technically are binary. You mostly don't want to do that because, you know, if you take an HTML document, right, and it's just a basic boilerplate HTML, that's still a lot of text, and converting that all to binary and writing it all in binary is like a super big pain. So it's recommended greatly just to let it compile it for you and send it over. Um, Same thing like why don't we just write everything in assembly or machine language? It's because it's really complicated to do that, and it's easier just to do it with like C or other languages.
Okay. Has anyone written or made a website with binary?
Probably. back in the olden days, it's probably popular to do that. But with HTML, um, technically you're writing in binary, but it's just like when you like typed in chat right there, technically you were typing in binary. Um, like when Bob said maybe, you're typing in binary, but it's just being shown to you as English text.
Okay.
Yeah, cool. So next up, we'll just do another challenge. So go ahead and try and write like your first name, if your first name's short, or if your first name's pretty long, you can go ahead and write any word you want. And take your time. It can be anything you want. Hey Bob, what's your question? Oh, those are just the weeds of Teach2Learn. So, yeah, so just go ahead and type whatever word you want in binary in the fun box discussion. Take as long as you want. Um, we'll wait for everyone to get that in. Bob, those are just the Teach2Learn heads. So, like, they run the managing operations for Teach2Learn. I don't know who the Sarah person is. You're fine, Bob. You're fine. Cool. So we'll just wait for those words to come in, and if anyone has any questions or needs help with it, just let me know. And just to make it easier on y'all, I'm gonna bring up a little thing for you here. Uh, yeah, you're fine, Dark. You're fine. I'm going to bring up a thing, so so you don't have to loop over the alphabet while you're writing it. Here's just the numbers for each of the letters.
Hmm?
If you already wrote it, it's not a problem. These are just the letter number representations in binary, so you don't have to like go A, B, C, D a bunch of times. Alright, I see Dark and Bob got it in. So, for example, for Dark, I'll decode it on screen for y'all. Okay, so first you can see, Dark just wrote an A because he just had his 1 in that, and then he wrote a 4, so that'd be D, and then he wrote a 6, so EF. Oh no, he had another one here, so 16. I'm reading the right one, yeah. 16, 20, 22. So 22nd letter is so 80 V
I think I might have gotten this wrong, guys.
A.
Can you pull up the chart with all the letters again?
Oh yeah,
The
sorry. Here you are. Hey Bob, if they're messaging you, just please ignore them. Just and leave them alone. So just don't respond to them, and they should go away. Nice, Sanjin got his in. All right. So just looking through Mr. Dark decoding it. It says Advay. Is that what you're going for? Advay.
Yeah.
Great. Yeah. So you got it. Very nice. Mr. Bob looking through. So you got A. Looks like your binary is kind of whacked up for the second one. So you may have to fix that one up. If you see like you got a very long one, and you have like a short one, just make sure they're all 8 numbers in total in a group. No problem. Let's see, and then one, okay, Sanjay, 1, 2, 3, 4. So I see you didn't put the 0 in front of the 1, Sanjay. Sanjin. Can you say your name again? I'm sorry. I have a bad thing with names.
It's Sunjin.
Oh, okay. Yep. Sorry about that. Yeah. So you did good. I think you just remember to try and put 8 bits per byte because you can have issues
Oh,
if you don't do that. All right. Let's see what.
yeah,
And we're using lowercase values.
yeah.
Great. Yeah. So the lowercase values, you just add a 1 to the 32 one. So it'd be 0, 1, 1, and then you can go on. Let's see. Get it right. Cool. So Sanjin got his name. Very nice. Very nice. See how Jacob did. All right. Let's see. 1001 001 1000 011. So Jacob, on one of yours you have a very long one that has more than 8. It's the fourth one. Can you check that one real quick? It's 010010111111. Besides that one, it does look good. I think you're trying to write Jacob right there. Very nice. And then Mr. David.
Oh, how's everyone, guys?
Hey, Alex.
Hey.
So let's see. David wrote a D, then an A, then I think, let's see. D, 1.
What are you currently teaching, Jack? What?
We're doing binary.
Nice.
All right, so David, you're looking pretty good. Only thing is on the third one, you would want another 1 in the 2's place. So you would want to put this for your third one, Mr. David, because you had a DAT ID instead of, if you put this instead, so it'll be at the right number, it'll be David. But still, great job on that. Okay, let's just make sure that works out for you, Mr. Jacob. Should be that. All right, all right. Um, Now I think you would actually want Mr. Jacob to do for ones like this instead, what I just posted. Um, because if we look over here, the one you're doing is trying to do an O. So an O is at value 79. So if we go over here real quick, you were doing 0, 1, 0, 0, 1, 0, 1, 1, which is 1 plus 2 plus 8 plus 64, which is equal to 72, 74, 75, right? So that's only equal to 75, so we need 4 more. So you would just want to make this one also a 1. So it would be 0, 1, 0, 0, 1, 1, 1, 1. Do you see how that works? Great, yeah. All right, so hey, you wrote your names in binary. Once again, give yourself a round of applause right there. Yay! Cool, and here, do another poll just to make sure you understand. So if you understand, just react with the A. If you don't, just react with the B, and we can go over it some more. And it's in the fun box discussion. Okay, great. So well, that was the that was most of the lesson today. So yeah, that was binary. Now, it's sort of crazy to think, right? Everything digitally that we have and everything on the internet is stored in what you just learned. The voice you're hearing right now being sent to your computer in binary, the books you read on your computer, the websites, all of that, it's all binary. Bob, that's slash poll, but just reserve that to us, okay? Now, yeah, it does get more complicated in some parts, right? So like UTF-8, you can go more than 8 bits to store more complicated information. But this general rule of 8 bits, you can move it around like that, is used pretty much universally. With numbers, you can make more and more, but this is some of the fundamentals you need to like understand to know how your computer's working, right? Um, So now that you know this, right, what can you do? So as you learn more programming, you'll come to see how using binary can greatly speed up certain operations. So if you've ever done, for example, a binary sort in Java, which is a special kind of sorting algorithm, or a binary search to search for something, it's super fast. And it uses a special way by using binary computations. We're not going to be going over that today, but it's in all ins and outs. It's in all realms of programming. Binary can help you understand more of what you're doing. You can also do fun things with it. If you're in class and you want to write some secret messages to each other, go in and write it in binary. Teacher probably won't understand, and you can have that secret messaging with your friends.
But wouldn't your friend probably not understand too?
Oh, we gotta teach them. You're now the teachers, bro. You gotta go out and teach everyone binary.
Bruh, that's gonna be hard.
Hey, no worries. I believe in you. I believe in you.
Jack, are you teaching binary and stuff? How does it like, bro? I think I kind of forgot how it goes.
Yeah. Hey, I got the video here, bro. I'll send it over.
Yeah.
So,
Just so you guys know, like learning this kind of stuff is actually one of the most important things for computer science. It's not just all about coding because learning this stuff kind of teaches you how does it like when you write programs, what is actually going on with the computer, right? Like for us, I'm sure Jack too. Like a lot of us lose sight of how it actually works because we just type in stuff and the computer does something, right? But there's a lot more behind the scenes than just that. A lot of like ones and zeros and stuff that are really important. And I see through what he's showing you, like the binary and how that generates numbers, how that generates letters. You guys can kind of see that it's not just type in a word and that's how it works. It's a lot more. It's a lot more than that.
Yeah, so well, at this point, we were supposed to go into some mini programming lessons, but due to this being the first time we're on and having to help with Discord a lot, we're kind of out of time. It's it's
Yeah.
1:30, so I will post a link to a collection of slides that I have in Funbox discussion, or some different languages if you want to go over them before the next. We're going to be going back to them, so don't use all of them if you are going to. And if you ever want me to give you mini challenges, you can always just send me a message. I can hook you up with some to have you do. But other than that, that should conclude for today. So here I can just
Yeah.
it
Make
does.
sure to stick around for the next workshop because of course, today was a little bit of an introductory thing with Discord and all that stuff, so it was a little slow. But as soon as we get the thing rolling, the next couple workshops will be you guys, learning the code and all that fun stuff. So
Yeah.
just for the first time, we're new at this as well, so really get better. It will get better.
All right, great. Oh, Mr. David, next class we're going to have another computer science topic. Still working with Katie, find out which one we're going to do. We have some planned up. And we're also going to do more of the programming stuff. So I hope to see you there. And here's also a little meme for y'all. All right, cool. Computer science jokes, right? So y'all are free to go. If you got any questions after this, feel free to message me, and I appreciate y'all being here today.
Thank you so much.
And no problem, Jacob. Take care, man.
I don't understand it.
Oh, so this is XKCD. It's a computer science thing. So on a scale to 1 to 10, how likely is it that this question is using binary? And the dude says 4, but there's no 4 in binary. You see what he's doing?
Wait, but isn't there?
Well, no, there's just ones and zeros.
Okay.
Yeah.
Alright.
Yeah, no problem. Computer science. I never say computer science jokes are the best. All right, cool. I'm gonna stop the recording here.